So we are on a new chapter now. So we need to know some of the trigonometric identities. So we first start with the very basic one, which is this one here. So let's look at the trigo ratio. What is the trigo ratio of sine theta? If you have this diagram here, whereby y will be your opposite, your adjacent is x, and your hypotenuse is is your radius. All right, so this is r. So what should my trigo ratio for sine theta be? Y over r. Okay, very good. Then, so cosine theta now? It will be adjacent over hypotenuse, and finally tangent theta should be y over x. So what are we doing? We are using the acronyms Picasso, all right, to help us. So now, you look at sine, cosine, and tangent. I can express tangent in terms of sine and cosine. Tangent theta equals to what? It must be having sine theta and cosine theta inside. Yes. So tangent theta is sine theta over cosine theta. This is the very first identity we need to learn. Can you please take note of that? Okay. Okay, now next. 1 over sine theta, there's another name for it. What do we call it? So I hear the word cosecant, right? How do I check whether it is correct or wrong? Yeah, look at the third letter, please. The third letter is S, and sine also start with S, so it should be correct. Please double check. 1 over cosine theta, what is another term for it? Yeah. Now, these two are the ones that I always make a mistake when I was a student. Okay, the last one, very hard to get wrong one. Yeah, it sounds exactly the same as tangent. It is cotangent theta, right? How to simplify sine square theta plus cosine square theta? All right, I start first and then I will pause the video, let you all try out. So sine square theta, I will use the trigo ratio y over r square, correct? I just square this only. Okay, then I plus the cosine square theta will be x over r square. Okay, now you try. What do you get? So to speed you along a little bit, this will be y squared plus x squared over r squared. And the question is, why is it called the Pythagorean identities? Why is this called that? Because we have to use Pythagoras theorem. So what will happen is, if we apply Pythagoras theorem, we will have x squared plus y squared. What will we get? Equals to r squared, right? Now, because this is a video, I will just erase that. Doesn't matter. So x squared plus y squared, we change it to r squared. And r squared over r squared, we will get 1. Sine squared theta plus cosine squared theta equals to 1. Now, we are going to derive 2 more. So what you need to do is divide every term by cosine squared theta, divide every term by cosine squared theta, divide every term by cosine squared theta, and then simplify it for us. The next one, the last one, divide everything by sine squared theta, sine squared theta, sine squared theta, and you will derive your own second and third identity. Can we do now? Simply tangent square theta, cosine square plus cosine square theta over cosine square theta plus 1, and finally 1 over cosine square theta is secant square theta. Now this can only be 1 equal sign. So for the sake of consistency, right, what is going to come out in the formula sheet is actually secant square theta equals to 1 plus tangent square theta. This is what is coming out in your formula sheet. Please do not derive it. Sine square theta plus cosine square theta equals to 1. The second one is secant square equals to 1 plus tangent square theta. All right, the last one, I think we can do it on the spot. Sine square theta over sine square theta is 1. Okay, now this one is a bit challenging, but after a while you get used to it. Sine over cosine is tangent. So cosine over sine is the inverse of it. So this will become cotangent square theta. Okay, pause here for a while. Who can't see this? Sine over cosine is tangent. Sine over cosine is tangent, right? Cosine over sine. All right, now every time we flip it, we know it is the inverse of this. And if the inverse of tangent will give us, by definition, cotangent. And the final one, come. The final one will be 1 over sine square, say out, equals to cosecant square, cosecant square theta. Now, what is going to come out in the formula sheet? Cosecant square theta equals to 1 plus cotangent square theta. So our aim here is to prove that the following identities is true. The left-hand side equals to the right-hand side. There are a few rules you must try to follow. Number one, so it must be a step from the left-hand side all the way to the right-hand side. You cannot do half on the left, half on the right. We will not accept it. In case you don't know, left-hand side, usually we write it as LHS. Right-hand side, we write it as RHS. In case last year I was teaching my student, then they asked, what is LHS? It's left-hand side and right-hand side. All right, so what we do is we do this. From the left-hand side, we will start now. And we will try to simplify it such that it will look like this. Okay, I will do it in the shortest possible manner. So what will happen is I change this to 1 minus 1 over sine square x, which was what I was doing just now, just only. But I want to leave this here for a moment, which is expand the denominator will be 1 minus sine square x. The idea is I still want to leave my sine x and my cosecant x there. So this becomes sine square x minus 1 over sine square x. Okay, I'm changing the numerator to become this. Then I have over 1 minus sine square x. I move this out a little bit. Please follow. Sine square x minus 1, the numerator is still the same. I just shift this out a little bit, so I times 1 over 1 minus sine square x. Again, the denominator is 1 over 1 minus sine square x. I just shift out a little bit. So what I did was I shift this out. Now, why do I do that? Why do you think I do that? I'm almost done already. I left with 2 steps only. Yeah, later you go and do a shorter one. Okay, so do you realize that this one and this one almost can cancel already? You learn this in Emacs, I can almost cancel this up. Okay, yep. Later, it doesn't matter which one you put negative, but as long as I change one of them to a negative, as long as I change one of them to a negative, this one can become this. Okay, then we will cancel away, right? We'll cancel this away. And what we are left with 1 over sine square x. And we know that 1 over sine is also called negative cosecant square x. Then we are done now. So the left hand side equals to the right hand side.